Hello guys, welcome back. So today I'm going to talk about a free fall motion problem. So let's take a look at this free fall motion problem. Let's see how we can solve it. Okay, so this is the question. So it's a free fall motion problem. The object is dropped, so that means it starts from zero velocity. The question is this: what is the distance fallen during the third second? Okay, we want the distance fallen during the third second. Okay, so free fall means we have free fall acceleration 9.8 meters per second squared downward in the downward direction. Okay, there's a constant acceleration downward with this value 9.8 meters per second squared, so free fall motion. Okay, so it's released from 0, t equals 0, and then at 1 second, so it's going to gain speed because it's accelerating, and then the speed is going to increase in the downward direction. So then at 2 seconds, this is the position, and then that's at 3 seconds, that's the position of the object, and that's the velocity vector. So what we need is the distance fallen during the third second. So that means we need this distance. Okay, so this is what we need. What is that distance? Okay, you might think we need this entire distance. No, that's for 3 seconds. That's for 3 seconds of the motion. But the question is asking the distance fallen during the third second. So that's the third second. Okay, that's the first second, that's the second second, this is the third second. So how are we going to find that distance? It's a distance. Okay, it's not a displacement, it's not a vector, it's a distance. So what I'm going to do is that I'm going to apply kinematic equations from the start to 2 seconds, and then again the kinematic equations from start to 3 seconds, and then subtract those two to get the distance during the third second. Okay, so let's go ahead and do that. So I'm going to use this equation: delta y is equal to v initial t plus 1 half a t squared. That's the displacement along the y direction, initial velocity, time 1 half, that's a constant, that's the constant acceleration, time squared. Okay, so I'm going to use this from 0 to 2 seconds. So I'm going to call that delta y2. What's the initial velocity? You can see it's dropped from at the beginning. So initial velocity is 0, so this first term is 0, plus 1 half 9.8, and then t is just 2. So I'm going to put 2 squared. I'm going to put 2 squared, and you might ask, why did you put 9.8? Shouldn't it be 9.8 with a negative sign? Remember, I'm going to consider downward direction as my positive direction. Okay, downward direction as my positive direction, so that's why I'm going to use the positive number. Okay, and then when you solve this, you're going to get 19.6 meters delta y. So after 2 seconds, the distance to the object from the start point is 19.6 meters. Now I'm going to look at from 0 to 3 seconds. 0 to 3 seconds, I'm going to again use the same equation. I'm not going to write that equation again. I'm going to use the same equation. So delta y3, again, like as you see, it starts from 0. So 0, that's the first term, plus 1 half 9.8, and this time I'm going to put 3 squared, right? The time, like after 3 seconds, what's the distance from the start point? So that's how you get that. And let's simplify this. So you have 9.8 times 9 divided by 2. So 9.8 multiplied by 4.5. So that's going to be 44.1 meters. Okay. Now we have these two values. Distance after 2 seconds from the start point, distance after 3 seconds from the start point. So this gap is basically the difference between those two. So what I need to do is I need to subtract 19.6 from 44.1 meters. Okay, and that's your answer. 44.1 meters subtract 19.6 meters, so the answer is going to be 24.5 meters. 24.5 meters. So if someone asks you what is the distance fallen during the 3rd second, if an object is dropped from a certain height, so that means the distance traveled during that second, the 3rd second, the answer is going to be 24.5 meters, guys. So that's how you do this problem. It's a rather complicated free fall motion problem, but hopefully you understood it. Okay, see you with another problem like this later. Bye for now.